Hello, welcome to Mathematics with Simon. I'm Simon, and that is Chewy. Today we're going to look at differentiating cubics, calculus. So let's start with y equals x cubed, the most basic cubic. Here's a picture of the graph. It's absolutely beautiful. Starts in the bottom left, comes up, starts to flatten off, goes completely flat at 0, and then starts to get more and more steep as it heads off towards the top right. The point at 0 is called a point of inflection, where it goes flat, sort of pauses and then takes off again. We're going to try and work out the gradient of this curve. We're going to consider a small change in x, which is delta x, and then a small change in y, which is delta y, and then to work out the gradient we're going to work out delta y divided by delta x. So xy is on the curve, so that means that y equals x cubed because it's on the curve, and x plus delta x, y plus delta y is also on the curve, which means that y plus delta y equals x plus delta x cubed. So y plus delta y equals x plus delta x cubed. Then we can expand out this cubed bracket, which is x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed. Just as a reminder, this is an example of the fact that if you ever take x plus y cubed, that is equal to x cubed plus 3x squared y plus 3xy squared plus y cubed. You can see all the workings here. We just multiply out the brackets one by one, literally. And all we're doing here is just taking delta x in the role of y. So y plus delta y equals x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed. Then what we're going to do is, to get delta y on its own, we're going to take y away from both sides. So we take y away from the left hand side to just give us delta y. We take y away from the right hand side, but y equals x cubed, so we're going to take away x cubed, which means x cubed minus x cubed cancels, and we get 3x squared delta x plus 3x delta x squared plus delta x cubed. Then we're just going to divide by delta x, so we get delta y over delta x equals 3x squared plus 3x delta x plus delta x squared. Now, this is the calculus move. We let delta x get smaller and smaller and smaller till it goes down almost to 0, till it tends to 0. So delta y over delta x becomes dy by dx, and then 3x squared doesn't change, but 3x delta x goes to 0 because delta x is going to 0, and delta x squared goes to 0. So dy by dx equals 3x squared. Okay, this is what it looks like. So this is an even function, which means that if you put in minus 5, you get the same answer as if you put in 5. And it's quite an interesting fact. So we've differentiated an odd function. This is an odd function. So if you put in minus 5, you get the negative of if you put in 5. What's fascinating is when you differentiate an odd function, you get an even function. And when you differentiate an even function, you get an odd function. That's one of the things we'll see in calculus. If anybody would like to write a proof in the comments or do your own video, I'd be very interested. You're very welcome. That'd be quite fun. So if y equals x cubed, then dy by dx equals 3x squared. And if we multiplied by 4, so let's say y equals 4x cubed, then dy by dx would just be 4 times 3, 12x squared. So everything would just be 4 times bigger. Now, you can prove this from first principles, but it is true. So now we can say differentiate this. Based on this session and the previous calculus session, you can see that in the playlist if you're interested. We can differentiate this. So we just go through term by term and then add together the differentials of each term. So let's look at the graph to begin with. X cubed minus 2x squared minus 19x plus 20. So this can be factorised as x plus 4 times x minus 1 times x minus 5, which means it's going to intersect the x-axis at minus 4, 1 and 5. Those are all the points which make the function 0. because in each case one of these linear terms will become 0. So let's differentiate it. So the differential of x cubed is 3x squared. The differential of minus 2x squared is minus 4x. So we multiply by the 2 and then reduce the index by 1, so it becomes minus 4x to the 1. The derivative of minus 19x is just minus 19. And the derivative of 20 is just 0 because constants differentiate to 0. They don't change at all. This is what the derivative looks like. Again, we've got a parabola. And here's the original function. So, some things to notice. The derivative is 0 at about minus 2, not exactly. And at about 3, although not exactly. And what that corresponds to, actually, is there's a maximum of this curve at about minus 2, and there's a minimum at about 3. So the derivative is 0 at points where you might get a maximum, or you might get a minimum, or you might get a point of inflection, as we did with y equals x cubed. So if you want to find the maximums or the minimums, minima, then if you take the derivative and work out the points at which it's 0, that will help you to find the maxima and minima. The next step then is to look at the second derivative, which we will cover in a future video. I hope you've enjoyed this. Chewy and I have very much enjoyed doing this. If you want to see more in the future, please hit subscribe and hit the notification bell. I hope you enjoy your mathematics, and we will look forward to seeing you next time.